Okay, so let's go ahead and finish up congruence. We were on number 2, and I'll let you pause the video so you can try and fill in for all of the types of angles, for example, number 2 on the right. Okay, so now let's go over these examples. So number 1 was supplementary. Supplementary, the angles are right beside each other. So like an example here, be angle 7 and angle 8. You maybe had something different. You maybe did like 5 and 6, or 3 and 1, or 2 and 4, or 2 and 1. All of those work as well. Corresponding, we do same side skip. So I see for this one, the parallel lines are here and the transversal is right there. So if I'm doing same side skip, that would be like 2 and 6. So I skipped 4, but on the same side is 2 and 6. So angle 2 and angle 6. And then I see we have alternate exterior. So alternate, opposite, and on the outside, that would be like 2 and 7. Angle 2 and angle 7. For vertical, you're looking for the V, you're looking for like the crosses, and that would be like 3 and 2. Angle 3 and angle 2. You maybe you did like 1 and 4, or 5 and 8, or 7 and 6. Alternate interior, they are alternate, they are opposite, and they are on the inside. So like 4 and 5 would work. Angle 4 and angle 5. You maybe did 3 and 6. That's also fine. Same side interior. So same side, but on the inside of your parallels. So like 4 and 6. Angle 4 and angle 6. Same side interior, those sum to 180. Supplementary, they sum to 180. All of the ones in between, those are congruent angles. We also need to talk about our parallelogram properties. So all parallelograms have the 5 properties that we're about to go over. Remind yourself that a parallelogram looks like this. It has 2 parallel lines. The opposite lines are parallel. They connect, making this quadrilateral. And let's go over the properties. So number 1, we have that diagonals, they bisect. So diagonals bisect. Bisect. To bisect, so when we say diagonals bisect, that means when you have those crosses, like that line would be congruent to that line, and this line would be congruent to that line. They're cut in half. Number 2, opposite sides are congruent. Opposite sides are congruent, meaning the opposite sides have equal length. We also have opposite angles are congruent. Opposite angles are congruent. I'll draw our picture again. The angles that are opposite each other are congruent. So 1 curve, 1 curve, those are congruent. 2 curve, 2 curve, those are congruent. Number 4, we have consecutive angles are supplementary. Consecutive angles are supplementary. Supplementary. And that means that the angles that are right beside each other, they sum to 180. So Like if this was 80, this angle, then that would mean that this angle over here is 100. And then we finally have the opposite sides are parallel. And that just makes sense because we're talking about parallelograms. So opposite sides are parallel. We show parallel with the arrows or the carets. So one arrow, they are parallel. Two arrows, those are parallel. The opposites are parallel. And so we can talk about our special properties of parallelograms. So a rectangle, a rhombus, a square, those are all parallelograms, but they have some additional properties. So a rectangle, for instance, its diagonals are congruent. So this diagonal is the same length as this diagonal. And for a rhombus, it has that the diagonals bisect pairs of opposite angles. So now let me actually draw a rhombus. The diagonals bisect these angles, and the diagonals are perpendicular. So we got some 90-degree angles on the inside. And then a square has all of them. So the diagonals are congruent. The diagonals bisect opposite angles. These are 90 degree. And so split into like 45, 45. And then the diagonals are perpendicular. So we also have our boxes on the inside showing 90 degree. And so those are all of our properties. We have our parallelogram properties, which goes for all of these. And then we have our special properties for our parallelograms. And then finally, we have our triangle theorems. And these are just like our special properties that we need to remember about our triangles. Number one, we have the triangle sum theorem. This means that the angles sum to 180, the inside angles sum to 180, sum to 180. Number two, we have the isosceles triangle theorem. This states that if you have a triangle that has two congruent sides, then the angles opposite those sides are also congruent. Number three, we have the triangle mid-segment theorem. This states that if a segment joins the midpoints of two sides of a triangle, so like say this is your midpoint, meaning like this is the same length as this, and this side is the same length as that side, then the segment is parallel to the third side. Parallel, so I draw the carets, and I know it's a very tiny triangle. And it's half the length. So like if this mid segment was 2, then the bottom would be 4. And like if the bottom was like 6, then the mid-segment, what's half of 6? That would be 3. So that's your triangle mid-segment theorem. And then finally, we have points of concurrency. Let me spell that correctly, concurrency. And this is dealing with your the fact that if you have a triangle and you have 3 or more lines intersect in the triangle, there are 4 points of concurrency, so that's like your incenter, your centroid, your orthocenter, and your circumcenter. This we didn't really focus on a lot, but just be aware of it. And we're going to go ahead and turn the page now and work on our practice EOC problems. So number 1 right here, let me make that a little bigger. It says parallelogram FGHJ was translated 3 units down from the parallelogram F prime. All of these are prime. Parallelogram, the one with the primes, was then rotated 90 degrees counterclockwise about point G prime to obtain parallelogram F prime, G prime, H prime, J double prime. Those are all double primes because 2 transformations have occurred. So here is our graph. The transformations have occurred right here. This is our image. This is our pre-image. This is which statement is true about the parallelogram FGHJ and parallelogram F double prime, G double prime, etc. So let's read this. The figures are both similar and congruent. Well, similar would mean that they have the same shape, but possibly a different size. That's not necessarily true. Or they're congruent. So if it's congruent, it's also similar. So we need to think about that. And then B, the figures are neither similar nor congruent. So they're not similar, they're not congruent. C, the figures are similar but not congruent. So if that was true, then that means like a dilation has occurred. So we also need to think about that. And then D, the figures are congruent but not similar. Well, I already know that D cannot be true, because if the figures are congruent, then they are also similar. And let's think about the transformations that occurred. There was a rotation and there was a translation. So it's not just similar, because if it was just similar, then that would mean that a dilation occurred. So that gets rid of C. So then what do you think it is? Yeah, so it's A, that the figures are both similar and congruent, because a rigid transformation has occurred, therefore they're congruent. And if a figure is congruent, then it's also similar. If it's congruent, it's also similar. Let's move down to number 2. Consider the triangle shown. So remember that as we're taking these notes, you're writing it on a sheet of paper and you're also marking your answers. So like this would be like question 2 on your own paper. And let's focus. Okay, consider the triangle shown. Which can be used to prove the triangles are congruent? Pause your video. Okay, so which can be used to prove the triangles are congruent? Well, that would be angle, angle, side. Got an angle, then a side. So that would be answer choice D. Okay, so I'm going to go ahead and stop the video here, and then we'll finish the rest of the EOC practice problems in part 3.